Hi to everyone. In the previous video, we discussed about the interpolation search algorithm. Now we will discuss about the exponential search. What is meant by this exponential search? Exponential search finds a target in a sorted array by first checking smaller ranges using the exponential steps. Double the indexes. What is meant by double the index? We will see with the neat example. Then performing a binary search within the identified range. It is efficient for the large sorted data set. Compared the till now we are learned about the linear search, best and binary search and jumping search and interpolation search. Now we are searching, concentrating about the exponential search. How it will be executed, how it will be performed. This is the compared to the remaining algorithm. This time complexity is a more efficient execution compared to the all thing. So to understand that thing, we will explain this example with neat inputs. These are the values. Using these values we can explain the all the things. So this thing also, all the values in the array must and should be in a sorted manner, then only we can execute the program. So these are the values: 1, 4, 9, 15, 22, 25, 38, 42, 77, 85. So using this value, now we will explain this exponential search. What is meant by this exponential search? These values, see these values, every value will have some index number. This is the 0 is the index number, and 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the index values. Total we are having the number of values we are having 10. 10 number of values we are having. Okay. So we will start that one exponential. So what is mean by exponential? What is mean by this double? We are having this column doubling the index. What is meant by doubling the index, and how we will implement the binary search within this example? This is a, we can say this is a combination of the two algorithms. We can say that this is a exponential search. What is meant by that? See this one. So if you want to, what is the thing I want to, in this example, my target variable is 77. This 77 is presented in this array or not, I have to check with efficient manner. How I will check? See this one, the starting from the first element, that is the 0 index. Here the 0 index, we are having a of 0 is not equal to the 77. Yes, not equal to the 77. Then it will be double the index. It will be double the initially 0 is double meaning 0 only. But initially we will take it as a 1. Initially we take it as a 1. So after taking the 1, what is the value of the index array of 1? What is the array of index the 1? What is the value we are getting? 4. Here see, what is the value we are getting? 4. Array of index is 4, 1. Again we start the comparison with 4 is equal to the 77. No. Then what is the index value? In the previous index value is 1. So I'm making as a double the index. 1, when we do the 1 is a double. What is the double of the 1? 2. So see the example. We are having double the indexing. Double the indexing. So here I'm making the 1 as a double the indexing. Here I am making 1 is the double 2. So here 1 2. So what is the a value of 1 to a of 1 to, what is the value a of 1 to? 9. 9 is a of 1 to a of 1 to. What is the a of 1 to? Index the values. What the value we are having? A of index 1 of 2. Here a of 1 of 2. What is the value we are having? 9. 9 is equal to the 77. No. Again we will double this index value. What is the double the index value? What is the value I will get? 4. Immediately from this 2 index value to control is jump from the fourth index value. Control is jump from the this fourth index value. The what is the value in the fourth index value? That is 22. That is 22. Here with the fourth index value is 20. Now it will start the comparison. 22 is the equal to 77. No. Then immediately we double the fourth index value into the 8. 8. Then what is the fourth onwards? Fourth to they will be incremented to the eighth index. Within the eighth index, what is the value we are having? 77. Now it will check 77 is the equal to the target 77. Yes, element is found. If you observe in this example, if you observe in this example, the starting index value is 0. 0 will be incremented by 1. After that incrementing by 1, every time if the condition is false, that index value incremented by double. 1 to 2. Again the index value is 2. Then within the 2, the key values will be checking if that is condition is not for false. Again we are incrementing the index value into double. 2 we are incrementing in the 4. In the fourth index value also we are not the required the required target variable is not presented. Then again we are doubling the fourth to the index is 8. Then in the eighth position we are finding into the 77. This is the process how we will execute. To better understanding, here we find out the 77 is, so here we are find out in A of I 77 is found in position 8. So to better understanding this thing, I will take one more example, searching for 15. Searching for the 15, I am taking the one more example. Okay. Here, what is the target value we are taking? 15. 15 is presented or not. Same thing. What is the start? The searching of the algorithm start from the starting index, that is the 0. 0 we will compare with the 15. So 15 we will compare with the 0 index, that is 1, not equal. So the 0 will be incremented by the 1. Double means that is the 1. We will make it as a 1. Within the index 1 we are having the one more value called as a 4. The 4 with we will compare with the 15, it is not equal. So again we increment the index value 1 to 2 here. 1 to 2 we are incremented. After incrementing the 2 within the 2 index, what is the A of array 2 index? What is the values we are presented? 9. 9 will be presented. See 2 see to see here 2. What is the value we are having here? 9. Again we start the comparison. 9 is equal to the 15. No, condition is false. When the condition false, what we are doing? We are doing 2 will be increment doubled with 4. Within the 4 I am comparing. Within the 4 I am comparing. The control jump from the here to here, and within the fourth index I am comparing with 22. Now when the 22 is equal to 15, no, again within that we have to again check that the required target variable is the less than or greater than the that values. The 2015 is the less than that value now, so no need to increment the again this index value. When the target variable is the less than to the last index value, or the target variable value is the incremented index value is greater than the target value, we don't go for the jumping statement. Here see 15 is, so this is the less than symbol, not greater than symbol. 15 is 15 is less than A of I. A of I means 4. What is the A of I 4? What is the value we are having? 22. What is the value we are having? 22. 22. Here, what is the value we are having? 22. So the target value 15 is less than the this index value. This presented key value. Then we will apply. Then we will apply the binary search concept. What is meant by binary search concept? To kindly see my previous videos, you can understand easily. In this, the fourth value will be treated as a last index value, that is a high, and the previous index value treated as a low value, that is starting index. Based on this low and high value, we'll identify the middle value. What is the low value? 2. So to understand, to little bit understand our binary search, I am again explaining this binary search concept here. 2 plus 4 by 2. Then what is the answer I will get? Here we will get 6 by 2. 6 by 2 means I will get the answer call as a 3. This 3 will be treated as a middle value. This 3 will be treated as a middle value. This 3 will be treated as a middle value. Within that middle value, they will start the comparison. The target value and the middle value both are the same or not. If both are the same, it will go for the element is found. Otherwise, it will again do the binary search concept value only. This is the concept about the. So again, we will implement the binary search for that one. Okay, this is the procedure about the exponential search. We will see the algorithm, how it will be executed, how we will be implement the binary search after incrementing by. So in this example, if you observe, the we are ignoring 2 to 4, we are jumping means we are ignoring one element. After 4 to 8, if you are jumping, after 4 to 8 you are jumping, your 3 is ignoring. After 8, where do you will jump? 16. After 16, where you will, after 8 to 16 you are jumping means how many values you are escaping? Almost 7. 16 to you will jump to the 32. How many values you are skipping? 50. So these exponential will be useful for the more data set values. More data set values means it will if you want to implement the 100 values or thousands lakhs of the values, if you want to implement, then use exponential search. Here we are skipping element is high here. Your number of elements you are skipping and finding the target element. So now we will understand about the algorithm. What is meant by algorithm? Check the first element. If the element to be searched is at the first index, AR of 0, return the index immediately. First, immediately in the first, what they are trying to say, if your target variable is present in the starting index only, compare it and throw it, it is a element is found. Otherwise, go for the second index. That is a first one. That index number will be treated as a first one. Treated as a first one. Start with an index I. Start with index I equal to 1 and double the value of I. That is, if the starting is the 1, next 2, next 4, next 8, next 16. This is the meaning of the double the indexing. In the example also we see the term called as a double the index in the definition of the exponential search. Okay, next until AR of I is a greater than, until up to where to we have to double this index value, until AR of I is the greater than or equal to the element you are searching for for or exceeded the array size. Up to where we have to increment, we have to double to exceed the array size, or that value is a greater than or equal to the element you are searching. Up to that, we have to double the index number to search for the particular element. If it is not found, element is not found. If the greater than value, if that index value, if the required target value if the target value is the less than the index value, then we stop the yes, we will stop the increasing of the doubling of the index value. Then we will apply the binary search concept. That thing will be added in the this next step. Once a range I by 2 I is found where the element might lie, perform a binary search. Yes, now we discussed that one. Between indexes I by 2 and minimum I comma n minus 1 where n is the length of the array. Return result is if the element is found, return its index. If not, return minus 1. These are the algorithm concept. So there is one more in the little bit I am discussing about this algorithm step by step. In the starting only, the index value is 0. With the starting index only, if the required or target variable presented, then element is found. Return the element is found. Otherwise, in the second index, that is called as a starting from the 1. Compare the value. If the value is found, no problem. Return the index. If your value is not found, increment, double the index value. What is the index value now? 1. Make it as a double. So 1, what is the double of 1? 2. After 2 index value, again set the key value with the target value. Then if the both are not same, again double the index value. Here the index value is 2. So we are doubling into the 4. Again 4, if your required target value is not present in the fourth index, again increment by the fourth value, double the index value, that is a 8. After 8, if the target value is not matching and the target value is less than value of the that 8th index value, then stop the doubling the index value. Then apply the binary search concept for the left side of the array to find out the element. What is meant by binary search? In the binary search, we have to identify the starting index as well as a last index. By using these two parameters, we will identify the middle value. If the middle value, after identifying the middle value, we compare with the middle value with the targeted value. If the middle value and target value both are the same, element is found. Otherwise, what we have to do, again we have to check one more condition. If the middle value is, our target value is less than or greater than of middle value, then we will move to the left side. If the target value is less than the middle value, we will move to the left side. If the target value is greater than the middle value, we will move to the right side. Again we apply the binary search algorithm. So like that, binary search will be applied. First we will apply the doubling index. After doubling the index, if you find out, that is a good thing. If not find out, then we will apply binary search algorithm. When the targeted value is the less than the that indexed value, then we will apply the binary search algorithm. This is the concept about the exponential search. We will see the pseudocode how it will be work. So we have to implement two algorithms here. This is the binary search algorithm and this is the exponential search algorithm. So what happened exponential search algorithm? We are having the two parameters ARR and target. What happened with ARR? ARR will be having the total array values within the target value, which keyword you want to search, that will be presented. ARR of 0 is the starting index is equal to the target index, then return 0 element is found. Otherwise, index make as a index as a 1. We will start the comparison for the second element, that second element index value is 1. Here the while condition is will be take the main crucial part. We will check that one. Index is 1, 1 less than length of array. Length of the array. 1 is the length of the array, less than the length of the array, we will move. And we will apply here AND condition. ARR of index. ARR of index is the 1. 1 the index value, within the first index value is less than or equal to target only, we will enter into the while loop. Here after entering the while loop, we will increment the index value into double. Index value is 1, 1 into 2, we will increment. And if not, return binary search. If not, we will return into the binary search. Binary search, we are passing the array value and target value and index by 2. Again, we do the index by 2, we will do, and we will identify the minimum value. Minimum function. Minimum is the predefined function presented in the Java or C++ or Python, not C++. Java and Python we will find. We will pass index length of array minus 1. How it will be work? It will call the binary search. Again, we will implement the binary search concept. Low less than or equal to high, and we will identify the middle value using the low plus high by 2. If the middle value is equal to the target value, we will return the mid value. Else if, again we will change the, if the array of mid value less than the target value, we will change to the right side, else we will move to the left side using this adjustment of the low value and high value. This the process will be applied in the binary search concept. Okay, I think all of you clear in this thing. So now I am going for the Program execution part. Program execution part. Here I am using the C language. First we will explain using the C language. Within the main method, what I am going to do. So we declare the array values. So better understand I am drawing the value. Here I will draw. One. How many values we are having? 1, 2, 3, 4, 5, 6, 7, 8. 8 values. 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. So I will also identify the index value. This is the 0, 1, 2, 3, 4, 5, 6, 7. I will insert the values 1, 3, 5, 7, 9, 11, 13, 15. These are the values, and this name of this array is ARR. So a better example here. See, this is the values we are storing, and this is the one important point about the thing. What purpose this n value? In the size of function is predefined function presented in the C language to know the how much memory will be allocating, how much size is allocating in the particular array. This will be depending upon the type of the array, it will be declared. So ARR is the integer array. So assume that for example, I am saying that is integer occupies 2 bytes. Within the 2 bytes, how many elements within the ARR we are having? Within the ARR, how many values we are having? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 2. It will treat it as here. 8 is the elements, number of elements. Next 2, 8 into 2, 16. 8 into 2, that is 16. 16 will be written by the here size of array. Next size of ARR of 0, only single element size. What is the single element size? It will return 2. Single element size it will return 2. 2. So 16 by 2, what the answer I will get? 2 ones are 2 eights are. I will get 8. I will get 8. 8 will be stored within the n. So here n will be stored with 8. Here x is the target variable is I am writing as a 7. Within that I am declaring the result variable. Within that I am declaring the result variable. I am calling the exponential search with 3 parameters. with three parameter. I'm calling the exponential search. This ARR variable is store the all the values 1, 3, 5, 7, 8, 9. That values will be presented. N will be store the number of element. X will be the target variable, that is 7. So here to control jump from the here exponential search. It will jump to the exponential search. In the exponential search, array will be initialized with all the values 1, 3, 5, 7, 9, 11, 13, 15, and n will be initialized the size, that is number of element, that is 8, and target value is 7. X will be stored, the target value is 7. Here what is the first condition in the exponential search? Exponential search, that is the first condition, ARR of 0. This ARR of 0, what is the values we are having? AR of 0, what is the values we are having? 1. 1 is equal to target value is 7? No. It will jump from the this line to this line, int I equal to 1 while I less than n. 1 is less than n. What is the n value? That is 8. 1 is less than 8, condition is true. And AR of 1. AR of 1, what is the value we are having? 3. 3 is less than or equal to 7? Both are the condition is true. Then immediately we are entering into the I value, we are making as a double. How I am making as a I value as a double? I equal to I into 2. What is the I value? 1. 1 into 2, 2. So now what is the I value we will store? Here initially I value is 1. After executing this line, after executing what is the I value becomes 2. Initially I value is I value is 1. Okay. After executing this line, 1 into 2, it will be again we are storing I value into override with 1 with 2. Then after control goes to from here to again same while loop. Again while loop only. Again check. Again check here. I value. What is I value? 2. 2 less than, what is the n value? 8. 2 less than 8. Condition is true. And ARR of 2. ARR of 2. What is the values we are having? ARR of 2. 5. ARR of 2. What is the value is? 5. 5 is 5 is, what is the target value? Target value is 5 is less than or equal to 7. Both are the condition is true. Then what we are doing? Again making, I am making as index value is 2. What is the I value? 2. 2 into 2, 4. Again index value I am making as a 4. Again I am making as a 4. After control comes from here to again jump to this one, again checking the I value. What is the I value? 4. 4 less than n, what is the n value? 8. So 4 less than 8, condition is true. Next ARR of 4. What is the values we are having? ARR of 4. ARR of 4 we are having 9. 9 is less than or equal to 7, condition is false. Here ARR of here 9. 9 is less than or equal to 7. Condition is false. Then what happens if the condition is false? It will goes to the if statement. If statement. What is the I value? 4. 4 less than, and what is the n value? 8. 4 less than 8. Condition is true. It will return the binary search. The control goes to the binary search. The control goes to the binary search. Within the binary search, what type of the values they are passing? Array. Total these values are passing. Here, the control is jump from this binary search. Array values, the array values total, these values will be carried, and I by 2. What is the I value? 4. 4 by 2, what is that 4 by 2? Again it will go for the 4 by 2, it will take it as a 2. 2. And what is the I value? Here 4. I value is 4. Here they will pass, here they will pass 2. They will pass 2. What is the target value we are having? The target value is 7. Target value is 7. This value will be passed here. Here int low. Low will be initialized with 2. High will be initialized with 4. 4. X will be initialized with 7. 7. Next, this array will be initialized the all the values. All the values will be initialized. What is the all the values? 1, 3, 5, 7. These all the values they will be initialized. Now they will apply the same binary search algorithm what we are implemented in the previous video. The same algorithm will be implemented here. While low less than or equal to high. What is the low value? 2. 2 less than or equal to 4? Yes. Next, they have to identify the mid value. What is the low value? 2. Plus, what is the high value? 4. 4 minus 2, we will get the 2 here. 2. 2 by 2, 1. 2 by 2, what is the answer I will get? 1. 2 by 2, I will get the answer called as a 1. 1 I will get. So low is the, what is the low value? 2. 2 plus 1, 3. Then what is the mid value it will be stored? It will be stored 3. Next after this line what it will be execute? If condition. ARR of mid, AR of mid, AR of 3. What is the AR of 3 value? Here, this is the AR of 3. This one is the ARR of 3. AR of 3, what is the value we are having? 7. We are having 7. What is the target value? Target value also 7. 7 is equal to the 7. Condition is true. Then it will be written the midpoint where this function is called. Where this function is called, same here they will be gone. They will be enter. After enter it is also returning the value. So here from to here where the exponential search algorithm is function call is called, it will return to this one. This one. Again the result will be stored with the index number called as a 3. Index number called as a 3. And the result we have 3. 3 not equal to minus 1. Yes, condition is true. It will print element is formed. This is the execution procedure of your exponential search using the C language. Same code we will explain in the C++. We will see the explanation in the C++. Here also in the C++ also we are declaring the variables here. Within the array we are having the variable int n. This is used to identify the number of elements presented in the array. This size of function is a predefined function. Using this function we can know the size of the total array, and this size of the AR of 0 single value size how much they are allocating. By dividing this thing I can know the how many number of elements presented in this. We can know this one. Next variable we are having the x variable. X variable, that is a target variable, x equal to 7. Then after we are having the result variable. Then after we are having the result variable, that is we call it as exponential search. Within that exponential search function call, we are passing the 3 parameter total array values we are passing, as well as a number of element I am passing, then as well as a target variable also passing. From here to the control will be jump to the this function. This function is control is jumping here. Jumping here, it will check the starting index value is equal to the starting target value. ARR of 0. What is the ARR of 0? That is 1. 1 is equal to target value. What is the target value? That is 7. Target value is 7. The size is 8. The size is 8. Total value is full. If condition is false, that will be come to the next line. I will be initialized with 1. I will be initialized initially. I value will be initialized with 1. I value initialized with 1. If the target value not matched with the starting value, then it will be checked. What is the I value here? In the while loop, what is the I value? Here I value is 1. 1 less than what is the n value? 7. So 8. 1 less than 8 condition is true. What is the ARR of 1? What is the ARR of 1? What is the values we are having? 3. 3 less than or equal to what is the target value? 7. What is the target value? 7. 3 less than 7? Yes. When the 3 less than condition is true, we are doubling the index and storing within the I. What is the I value? 1. 1 into 2, 2. Now I value will be reinitialized with 2. Then it will be goes from here to again while loop only, again while loop only. Here what is the now I value? 2. 2 less than what is the n value? 8. 2 less than 8 condition is true. And array of I, within the array of 2 what is the value we are having? 5. What is the value we are having? 5. 5 is less than or equal to 7, condition is true. When the condition is true, what they are trying to do? So here 5 is less than or equal to 7. Again it will come. Again I what is the I value? 2. 2 into 2, 4. I will be reinitialized with 4. I will be reinitialized with 4. Okay. Next, coming to the increment to the value. What is the 4? I value is 4 less than 8, condition is true. And ARR of 4. ARR of 4, what is the values we are having? 9. 9 is less than or equal to the 7, condition is false. When the condition is false, it will go to the binary search method. It will go to the binary search method. We are passing the values. Binary search method will be executed as usual how the previous program will be executing, and it will return the mid value and element is found. So in this, they will return the mid value to the exponential search where the binary search is making call. After this, from this, it will go to the exponential search. We will get the result. This is the procedure of the C++. And Java also, same thing we are having. So, so both the explanation is completed. Uh, that is with using C completed, C++ also completed, pseudocode and algorithm also completed. Now we go for the Java coding. So here we are having the same values in the Java also. So array dot length is a predefined method to find out the length. Target variable is a 7. The result variable will store the result of the finding element. The exponential search passing the 3 parameter array and the size of the element and the target. From here to that will be jumped to the from to here. Within the explanation, all the values will be initialized with ARR. So here int n will be target value. So int x is the target value, that is 7, and n is the size of the element. That the size of the element is the 8 we are having. Here is the we are checking that first element is the first element AR of array within the array, the first element is equal to the target element. Then we will element is found, we will return to the element is found. So we will draw here to better understand. I'm also write the index values here. 7. I'm inserting the values 1, 3, 5, 7, 9, 11, 13, and last one is the 15. These are the values we are having, and name of this thing is ARR. That is the array. ARR is the values we are having. So going to this explanations, from the exponential, it will jump to this one. We are having the target value is 7 and number of element is 8. ARR of 0. What is the ARR of 0? What is the value we are having? 1. 1 is equal to target value 7? No. So it will jump to the next line. Here we are declaring the integer I value and initialized with 1. So I value will be initialized with I value will be initialized with 1. Next we'll checking the while condition I value. I value is the 1. 1 less than n value is the 8. 1 less than 8 condition is true, and we are having the AND operator. AND operator means both the condition must and should be true. Here ARR of I means ARR of 1. What is the ARR of 1 value we are having? 3. 3 is the what happening here? Here 3 is less than or equal to target value 7. Yes, condition is true. When the condition is true, the control enter into the while loop. In the while loop, what the condition we are writing? I equal to I into 2. What is the I value? 1. 1 into 2, 2. Again, this 2 will be placed within the I value. I value. So again, it will control jump from this to again while loop. Again, while loop. Again here I value is the 2, 2 less than 8, condition is true. ARR of 2, what is the ARR of 2, what is the values we are having? ARR of 2, 5. 5 we are having. 5 is less than 5 is less than or equal to the x 7. Yes, again entering into the while loop. What is the I value? 2. 2 into 2, we are making the double here index value. Here a double index. I will be replaced with 4. I will be replaced with 4. Again control jump from to here line. 4 is less than 8. Condition is true. And ARR of 4. What is the ARR of 4 we are having? ARR of 4 we are having 9. ARR of 4 9. Now check it. 9 is less than or equal to 7. Condition is false. When the condition is false, it will go to the return function with the binary search. With the binary search, they are passing the parameters. They are passing the total array. I by 2. I by 2 means it will pass 4 by 2 means it will pass the 2 and mass dot minimum. What is the minimum value? I value is the 4. I value is the 4. N minus 1. N minus 1 means 8 minus 1. That is 7. Within that, which one is the minimum? 4. So it will pass the 4 here. It will pass first to 2, next to 4. Next, what is that? X will be passed. X will be what we are having? 7. 7 it will be passed. So it will be control from goes to here to again binary search concept. Again binary search concept. Here total in this array, total values will be presented. What the values? 1, 3, 5, 7, 9, 11, 15, 11, 13, 15. These values will be presented within the this thing. Int low. Low will be initialized with 2. High will be initialized with 4. The target value initialized with 7. Again it will apply the binary search concept. binary search concept while loop, and it will return the mid. And again it will return to the return this statement. From here to it will return to the result, and the result will be displayed the here element is found. This is the process about the Java. Similarly, same thing will be happened within the Python programming. With the Python programming also, we are having array initialization 13579 and length of the array, target variable, same exponential such as the three parameters will be passed. If the starting element is found, it will return 0. Otherwise, I will be initialized while condition is checking, and we are doubling the indexing. If the condition is false, it will returning the binary search. Binary search will be perform the action according to the binary search rules. Again, it will return to the same binary search, and binary search to the exponential search, the result will be found. Like that, the Python programming also work. This is the procedure about the thing. So same if you observe within that, if you are seeing C language code, C++ language code, as well as you also seeing the Java language code and Python code. Four language codes are you seeing. Within that, most of the code, the logic, the way of writing the code is the 90% is the same. But compared to the C, C++, little bit, only 1% of the code different, like printf and cout. Remaining all same. Function calling, called function are the same. Comparing to the C++ Java coding, the everything is the same. Little bit the different in the function declarations and function calling. Instead of the cout, we using system.out.println. The function declaration, we have extra keywords called as public static. Here we are having the some class concept instead of the C++. Compared to the Java to Python, we don't have any declaration of the variables in the Python language. And in this key, if you want to declare in the functions in the Python language, we use the def keyword. Using that keyword, we are executing the all the program. That is the basic difference we are observing. Now we will execute these four programs to better understand. So now we will see this program. C program. First we will execute the C program. We will wait for loading. Just compile it. Element is found index number 3. Okay, we are changing the target element. Instead of the 7, I am changing target element to the 13. So tell me, what is the index value of 13? 0, 1, 2, 3, 4, 5, 6. What is the target value of the 13 is 6. Now we will check. See the output target value is 6. Sir, I want to read the target value from the keyboard. How to read using the keyboard? Simply write printf, enter a, enter target value which you want to search. Then we use the scanf method with the percentage d symbol, comma, and percentage x. Then it will work. Here we have to initialization, you have to remove. Then after you have to compile the program. Scanf what we are having semicolon. We are missing semicolon. Compile it. Oh, we are putting inside. Just enter the target value, and so I am entering the 88. What is the answer I am getting? Element not found. Element is not found. This is a thing. So again I am compiling. Here I am target value search. I am searching as the 15. What is the 15th index value? 0, 1, 2, 3, 4, 5, 6, 7. Index value it will be print 7. So one more execution, final execution. That is the first element. Element is found index 0. Okay. Next I will go for the execution of the C++. So element found index number 3. Here also we will change the target value 30. Index value is 6. Here also we can have the read the key index from the read the target value from the keyword. C out. Within that in the C we use the printf. In the C plus we use the C out. Enter target value to search, and the semicolon is the mandatory. Cn x. Here we are doing it out. Now compiling. Now in compiling. Enter target value to search. I am target value I am making as a 9. So one more example. I am entering target value 678. 7 element not found. One more time execution. That is the target value is 3. Element found at index 9. So this is about the C++. Okay. Now we will check about the Java. I am removing all the commands. We will get error. Why we will get the error means the class name the class name must and should be main M capital. Here we have to rename our class name. We have to remember when we are using the Java Online compiler, the class name must and should be the main, because they write the file name as a main.java here. So the file name class name must and should be same. Then only the program will execute. This is the minimum basic process. Index number is 3. Okay, and changing the target value 70. What is the output I will get? Element is not found. So element is not found. Okay, I'm changing the target value is 7 to 1. So target index value at the 0. Okay, this is the basic one. Now I'm going for the Python execution. In this also we can read the keywords. We'll get the error, I think so. Here we have to remove this symbol. So element found index number 3. So now we'll change the index also 17 to 13. Index 6. I'm making as a 130. So element is not. So you can use any online compare for the execution for a practice. So this is the thing about the total thing. Coming to the all the slides. So within this, I completed linear search, binary search, jump search, interpolation search, exponential search. 5 concepts are completed, and we will discuss about the depth first search, breadth first search, substring search, hash search, ternary search, and best first search, ace search, uniform cost search, and bidirectional search, iterative search, greedy search, Norris pattern, Rabin crop. So we have so many algorithms to calculate. That will we will search. We will explain. In the next video, we will discuss about the depth first search. This depth first search algorithm we will discuss in depth first search and breadth first search. Both the things we will discuss how it will be executed. All those things. It mainly useful in the graph technology. In the graph flow, we will use this one within the graph. This is the diagrammatical representation, and this is also having the algorithm, pseudocode, code for the C, C++, and Java, Python, and breadth first search. This is also graph concept only. Next, this is also having the steps, pseudocode programs, stocks, and code, the representation. If you observe in the exponential search, mainly it will useful for so big data set like that. Uh, if you want Aadhaar card numbers, Indian Aadhaar card numbers, if you want to search within that Indian Aadhaar card number, that type of the searching is very useful. Is a multiple 16, 32, first 0, after that 1, 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, 32, 64, 128, 256. Like that, it will be increasing and implementing the binary search tree. This is most useful for the large amount of the data set only. You have to practice, you have to write your own code, you have to write own algorithm, own source code, own implementation, C, C++, Java implementation you can make for the execution. So this thing about this one, so everything will be presented. Substring search also very useful. So in this substring concept will be useful in the our mobile phones. The contact address, this substring will be useful. How the our contacts, if you are having the 2000 plus contacts within that, if you are having within the context, if you are having the 20 characters of a string, within that if you type the 3 keywords, it will search in the 3 keywords, 3 characters only, it will show to you where the exactly name is presented. This is algorithm also most important for your gate examinations. And next, hash search also. Hash searching also most important concept. How it will be work, we'll discuss in the next video. Thank you, one and all.